Let's look at the solution of geometry bites. In the triangle ABC given below, DE is parallel to BC. If DE is parallel to BC, instantly you should be arriving at the conclusion ADE is similar to ABC. Now we are told AD is to AB is 1 is to 2. AD is to AB is 1 is to 2. So if AD is to AB is 1 is to 2, if this is X, this entire thing is 2X, or DB is also X. AD is to DB is 1 is to 1. Also, AE, if it was Y, EC will also be Y, because the ratio of AD is to AB and AE is to AC should be same, because they're similar triangles. Next, we are told AD is to EC is 1 is to 1. AD is to EC is 1 is to 1, which would mean this is also X, and correspondingly this is also X. So by now we are sure that ABC is an isosceles triangle. ABC is an isosceles triangle. This much we know. And D is equal to 4. Now if D is equal to 4, we know that DE is to BC should be in the ratio 1 is to 2. So we know BC is 8. This is also known. What is the value of angle B? Now the value of angle B, that cannot uniquely be identified. The only conclusions we can reach are AD is similar to ABC. ABC is an isosceles triangle. AD is an isosceles triangle. Length of BC is 8. The ratio of length of sides of AD and ABC is 1 is to 2. But about the angles, we cannot conclude anything definitively. And therefore, the answer has to be option D, indeterminate. Next, in the given figure below, AD is equal to AE is equal to 4. Okay, so this is 4. This is also 4. And BD is equal to CE is equal to 2. Okay, this is 2. This is 2. If BC is a straight line, okay, an angle ADE is equal to 60 degree. So if this is 60 and AD was equal to AE, this will also be 60, which would mean this angle is also 60. Cool. Find the length of AB. Okay. The good thing to see here is, given that ADE is effectively an equilateral triangle, DE will also be 4. DE will also be 4. But in addition to that, can you see that ABD and AEC are ADB and AEC are congruent triangles? One side equal, another side equal. The angle between them 120 degree, 120 degree. This is also equal. So AEC and ABD are congruent triangles, which would mean this side and this side are also equal. Wonderfully well done. I'm dropping a perpendicular from A to BC. I'm dropping a perpendicular from A to BC. Given that ABC is an isosceles triangle, can you see this perpendicular that has been dropped? Let's say at point M, BM will be equal to 4. BC in total was equal to 8. So BM will be half of that. BM would be equal to 4. Additionally, because AM is also the height of the equilateral triangle, AM will be equal to 2 root 3 or root 3 by 2 into 4 height of the equilateral triangle. So we get 2 root 3. So now if I need the length of AB, I know AB square is equal to 4 square plus 2 root 3 whole square, or 12. AB square is equal to 28. AB is equal to 2 root 7, which is the first option. Next question. A sphere of radius r is melted to form a cone of the same in radius. 1 minute, I'll have to take a pause. Let's look at this question now. A sphere of radius r is melted to form a cone of the same radius. What is the ratio of the total surface area of the sphere to that of the cone? Okay, so because a sphere is being melted to form the cone, then their volumes are going to be identical. So 4 by 3 pi r cube is equal to 1 by 3 pi r square h. 3 and 3 gone. pi and pi gone, r square gone, r square gone. We effectively get r is equal to, h is equal to 4r. Now finally we need total surface area. Total surface area for a sphere is given by 4 pi r square, and for a cone it is given by pi r square plus pi r l. L is the slant height. Now the slant height is given by under root h square plus r square. H square will be 16r square. R square is this. So can I say it will be r root 17? So this expression will turn to 4 pi r square by pi r square plus pi r square root 17. Pi r squares will get cancelled from every place. We are left with 4 by 1 plus root 17. And that is option A. So that will be the answer. Next, in a triangle, the ratio of in radius to that of circumradius is 1:2. Find the area in square centimeter of the triangle if one of its sides is 22 centimeters. Again, this is a basic insight. The only triangle where this is true, where the in radius is basically what they're saying is the in radius and circumradius and median are the same line, or the in radius, the circumradius, and the centroid, in center, circumcenter, and centroid are at the same point, and this only happens in an equilateral triangle. Effectively, they said if for an equilateral triangle with side 22, what is the area? The area is given by 3 by 4 into 22 square, which is root 3 into 11 square, which is 121 root 3, or option A. The only triangle where the in radius and circumradius are in the ratio 1:2 is an equilateral triangle. Okay, if ABCD is a quadrilateral and the circle is inscribed in it, then I hope you remember from yesterday's episode, this precise thing was talked of. If you have a quadrilateral within which it doesn't matter if it's a square or not a square, let's say A, B, C, D. This point is P, Q, R, and S. If this is X, this will be X. This is Y, this will be Y. If this is Z, this will be Z. If this is W, this will be W. So now fourth option directly I'm jumping to. AB is X plus Y and CD is W plus Z. DC is Y plus Z and DA is X plus W, which is another way of saying for any even sided polygon, although it says a quadrilateral here, even if let's say it was a hexagon, work with it. This is the tangency point, tangency point, tangency point, tangency point, tangency point, tangency point. If this is X, this is X, this is Y, this is Y, if this is Z, this is Z, if this is W, this is W, if this is V, this is V, if this is U, this is U. So look at these sides. You've got one X, one Y, one Z, one W, one V, one U. And now look at these sides. X, Y, Z, W, V, U, same thing. As long as it's an even-sided polygon, if a circle is inscribed within it, sum of lengths of alternate sides would be equal. That will be all for this episode. Hopefully you learned something.